Alright, hello everyone, welcome back to another video. Today I'm going to be showing you all how to plot the isothermic graph of water. So basically what we're going to be doing is we are going to be plotting pressure at different volumes and at many different temperatures for water, and we're going to be putting them all into one graph. And yeah, let's jump into it. So basically what we're going to be doing is we're going to be taking this equation of state that we've been using in the last few videos right here, this SRK equation of state right here. And basically what we need to do first is we need to make a function that is going to find these four values in here that we are not going to know. So right now we are not going to know the values for A, the value for B, the value for sigma, and the value for epsilon. So basically what we're going to need to do first is we're going to need to figure out what the values for that. And we're going to be using Python, and we're going to be using this document right here to help us figure that out. Alright, so the first thing we're going to do is we're going to hop on over here to Python, and we've already imported this repository over here that we're going to be doing. It's going to make our lives a lot easier. It's going to show us some of the properties of water that we're going to be needing to use later on in our equations. And yeah, it's just going to make our life overall a lot easier. So we've gone ahead and copied the link in there. So now what we need to do now is we need to import our system. And we need to do a path insert right here so that Python will know where to look, and we can go ahead and get our values in. So we're going to go /content/CHE-tools, and yeah, this is just telling Python where to look so that we can use our repository later on. Make sure that's running. Yep, looks like that's going good. Alright, so next we're going to import CHE tools, or not, excuse me, tools.che as CHE. Get that running. And yeah, now let's go ahead and get our properties of water going. So we'll use our callback as P for properties right here. And we'll go che.props, and then we want the properties of water, so we'll go ahead and say water, like so. Make sure that's running all good. Alright, and we'll go ahead and test this out, make sure it's running right, see if it'll give us the critical temperature for water. And yep, let's make sure that's the critical temperature for water. Yep, 647, so that's running good. Alright, so now we've got our repository all working great. The next thing we're going to want to do is we're going to import our subplots, because we are going to be making plots later on. So we'll go ahead and do that. We'll just do that right up here so we're not taking up too much space. So from plotly.subplots, we're going to import make subplots. Sure that's going good. Yep. Alright. And now we're going to go ahead and jump on into our function so we can figure out the values for our unknowns that we're going to be using later on. Alright, so this first function that we're going to be wanting to create here, we're going to want it to give us our values for the A, B, the epsilon, and the sigma here. So we'll go ahead and define a function for that. We'll call it cubic ABES, since those are the values we want it to return. We want it to return our A, B, epsilon, and sigma values. And yeah, we're going to be using temperature to do this. We're going to import the temperature in, so we'll go ahead and do that. Alright, and we're going to want it to solve for A, B, epsilon, and sigma. And then at the very end of it, we are going to want it to return those same exact values. So we'll get the return going. Those are the values that we're going to want it to return at the very end. And yeah, so let's hop on over here to this document. This document is going to be helping us a lot when trying to figure out those values. So as you can see here, we are using the SRK equation right here, and there's going to be a table down here that's going to give us some of these values right here. And if we scroll on over to the SRK, it is going to be telling us these values over here. So it looks like for the sigma, we know that's going to be equal to 1, and for the epsilon, we know that's going to be equal to 0. So we can go ahead and input those in. So E is going to be equal to 0 and S is going to be equal to 1. Alright, now we just need to get our A and B values in there. And we can find those up here, I believe. So it looks like the A of the critical temperature is going to be equal to, not sure what this Greek symbol is right here. But yeah, we can just go ahead and import any variable we want to for that, and then that's going to be equal to that Greek letter times r squared times the critical temperature squared over the critical pressure. Alright, and let's see here, we can go ahead and import r. That's just going to be a constant that we can go ahead and look up, so let's go ahead and look that up. Looks like that is going to be equal to 8.3145, so we'll go ahead and import that. R is equal to 8.3145, yep, 3145. So there we go. We can go ahead and, actually no, this was just for the critical temperature. We don't want to use that one. We want to use it at any temperature, so we'll go ahead and use this one down here. And we'll go ahead and for this little trident symbol, we'll go ahead and just use a T since it looks like a trident. So for A, it's going to be equal to T times alpha times r squared get some parentheses going on around there. And then for the critical temperature, we're going to go ahead and use our repository over here. So we're going to go times, get some parentheses, p dot tc, and then that's going to be squared. And then we'll get some more parentheses going around all of this. And then that is all going to be divided by this critical pressure here. So we'll go P dot PC. Alright, so now that we have our equation for A in there and put in, we are now going to have to go through and find out the unknowns that we have in our equation A. We currently do not know what the value for alpha is or the value for the trident symbol is, so we're going to need to go back through this document and find those. We'll go back on down here, and it says that the T value for the SRK is going to be 0.42748, so we'll go ahead and import that for our case. So we'll go T is equal to 0.42, go ahead and make sure we get this right, 42748, there we go. Alright, now we need to figure out what our value for alpha is. Let's see here. Here we go, it's right here the whole time. So it looks like the value for alpha for the SRK equation is going to be equal to TR over W. Never mind, it's right here, so we're going to go ahead and use this equation right here. So we'll input, alright, so this is all going to be squared right here, so we'll go ahead and add this out here. And then go ahead and copy what it has in here. So we've got 1 plus parentheses 0.48, 0.48 plus 1.574. Alright, and then we've got this little W symbol. We'll have to go back through and find out what this W symbol means later. We'll go ahead and just import it as W right now. Then it's minus, what was it again? 0.176 W squared. Go ahead and get some parentheses around that. And then that is all going to be multiplied by 1 minus TR to the 1/2. 1 minus, let's see what this TR is equal to. Not sure what that TR is. Hopefully we can find that somewhere in here. Let me see here. TR. Definitely should be given that. Oh, here we go. TR is equal to T over TC. So we'll go ahead and TR is equal to T over the critical temperature, I believe, over the P dot TC. There we go. So we are over here in our alpha equation. So we got, alright, let's find our equation again. Over 1 minus TR times 1 over 2, like so. Alright, and I believe that should be it for our alpha equation. Let's go ahead and make sure we got this right. Don't want to mess this up. Make sure we got all our parentheses going to the right places. Make sure we get a multiply sign over there. Alright, that should be good. Alright, so now we have our A equation fully done. Now all we have to do is go back through and do our B equation, and then this function will be all good to go. So let's take a look over here at our B equation. So B is equal to this little horseshoe symbol times R times the critical temperature over the critical pressure. So we'll go ahead and do B is equal to H times R times the P dot TC, which is the critical temperature, and that's all going to be over the critical pressure, which is going to be P dot PC, like so. Alright, now we just need to go back through and find this symbol right here. And for the SRK equation, it's going to be 0.08664. So we'll go ahead and import that in. H is equal to 0.08664. And yeah, there we go. That should be it for this function right here. Alright, so we did make a few mistakes in this first function over here. The first one being is we want t to be equal to 42748. We do not want that to be subtracted, so we'll go ahead and add that equal sign in there. And another one is that for these values of p, we do want that to be a property that we get from our repository. So we'll go ahead and make that p.w right here. And we'll go ahead and make that a p.w right there as well. Get some parentheses going on right there. And yeah, now this first function should be all good and ready to go. Alright, so it turns out we did make a few more mistakes over here on this first function. First one was we need to make this a lowercase d so that it is defining the proper function, and we also need to include a colon over here so that it knows where the function is. Alright, so we're going to go ahead and run that. Alright, so we did also make a typo over here. This needs to be alpha like that so it gets everything matched up. And then invalid syntax, what do we have here? R squared times Not sure what the problem over here is. Alright, so I went back and figured out what the problem with the syntax was. It actually is not in this line, it's in the line above it. We do need to add a fifth parentheses up here. Probably did go a little bit overboard with the parentheses. I usually do, but you can never be too careful, so I was like adding more than I need to. So this should be working all good now. Alright, let's just go ahead and rerun everything, make sure everything's working good. Alright, and now we're ready to get on to our second function. Alright, so basically what the second function is we're just going to be inputting this equation right here. We're going to be getting our p-value back while importing or supplying the volume and the temperature into it, and it's going to give us our pressure back. So we'll go ahead and we'll call this cubic pressure, and we will supply V and T to this function. Alright, and we're going to want this to return our pressure there at the very end of it. Alright, so we are going to need to import these values into this function, so we'll go ahead and go A, B, E, S. That's going to be equal to the cubic A, B, E, S, the T. Basically, that's just bringing in the A, B, E, S values that were returned from this function right here. Alright, and now we're ready to go ahead and input our equation for pressure, which we have over here. So we're just going to go ahead and write this in there. So P is going to be equal to V, let's see here, that's going to be equal to R times T. That's going to be divided by V minus B, and that's going to be subtracted by A times T. We'll go ahead and get an extra parentheses going on right there. Alright, so that's A times T over V plus epsilon times B. Alright, V plus E times B. That's going to be multiplied by V plus sigma B, I believe. Yep, sigma times B. Go ahead and get some extra parentheses going on around the outside right here. Not going to need that one there, I don't think. Alright, let's go ahead and run this and see if it's working alright. Alright, there we go. So now we have all the functions that we're going to need. Now we just have to go ahead and get to plotting our graphs, and yeah. Alright, so now we are ready to go ahead and get graphing our isotherms. So the first thing we're going to want to do is we are going to want to create our figure. So we're going to go fig equals make subplots. And then we're going to go fig dot add scatter. And then we are going to want our x values to be the volume. Should be an equal sign right there, and we are going to want our y values to be equal to the pressure. And to start off, we are going to make this a scatter plot, so we're going to want our mode to be in markers. So our mode is going to be equal to markers, like so. There we go. Alright, now we're going to want to define our volume and pressure so that we can create our ranges right here. So we're going to go ahead and set P equal to the cubic P of V and T, making our pressure equal to this function that we solved for earlier, like so. Alright, and then we're going to want to go ahead and pick a temperature for it to solve for. We'll go ahead and just make it 400 for right now, 400 Kelvin. You know, that's a nice easy temperature, something that you would expect in a function like this. Alright, and then for our volumes, we'll go ahead and give it a linear space for the values just to start out right here. So we'll go v equals np dot linspace. Alright, and then we're going to want our values to be based off of the value for our B over here. B is the space taken up by the molecules of gas in the problem, so we don't want our volume to be, any less than the space being taken up by the molecules. That wouldn't make any sense. So we're going to go, we'll do 1% bigger than B, so we'll go 1.01 times B for the minimum, and then we'll go about 1 e to the 6th times b for the maximum, and then we'll create about 1,000 points for this. That sounds pretty good. Alright, and then we're going to want to go ahead and put in our b's outside of the function, so we'll go ahead and put it about right here, and we'll just go ahead and copy what we saw for b earlier. So we'll go ahead and copy this into that, like so. Paste that on in there. Let's see, it's not wanting to do it for me. Go ahead, copy, and paste. There we go. And then we are going to want to manually input the values for the h and the r down here. We don't want it to be nested inside this function, so we'll go ahead and copy this h value in and paste it in for h down here. Here we go, and then we're going to want to go ahead and find the R value. We'll paste that into there as well. And we'll take a look at what this graph is going to look like right here after we get this pasted on in. Alright, let's go ahead and take a look about what our graph is going to look like. Just got to give it a second. Running a little slow. Let's go ahead and run everything else just to make sure everything else is working. Not sure what's going on here. Hopefully she'll get running soon. Maybe if we refresh our document here. Let's see, hopefully it saves it. Save failed. Alright, we don't want it to. Let's see, cubic is not defined. Oh, we want to go ahead and make this, what did we name this up here? Cubic P. Name fit is not defined. Oh, lots of typos today. Alright, so that is not what we want to be running here. That is not going to be right for us. So alright, so I found our mistake that we made earlier. It was in this function right here. We just want it to be A on top, so we're going to go ahead and delete the temperature right there. We're just going to have A over this right here, so we'll go ahead and rerun that and rerun this. Alright, that is looking better. That is how we want it to look at this moment. So right now what we're going to go ahead and do is, as you can see here, the function is going from very large numbers to very small, and it's doing that in a very quick manner. So in order to better visualize this, we're going to want to bring in we're going to want to make our x-axis into a log function just so we can better visualize the data and better be able to see what is going on in our plot right here. So we're going to go ahead and go fig.update, and then we're going to go x-axis, x-axes, and then we're going to make it into a log type. So type is going to be equal to log, like that. Let's see how that's looking for us. Alright, there we go. That is looking much better for us. We can much better visualize what's going on in the data right here. And the next thing that we can go ahead, in order to make this look better for us, is we can go ahead and add some logs into the y-axis up here, just so we can better visualize it again. So we'll add some np.log space. Actually, no. First thing we're going to do is we're going to make this into a log space over here. Alright, so we're going to get np.log space, and then we're going to go ahead and put some log functions around these over here, just so we can better visualize it again. So we'll go np.log10, and we'll get some parentheses going on, and we'll do the same thing for the maximum over here. We'll go np.log10. Like so. Alright, let's visualize what that is looking like for us. Alright, that is looking very nice. That's pretty much exactly how we want it to look right now. The next thing we're going to want to do is we're going to want to go ahead and add some different temperatures over here for this, because we're going to want to be taking this function at more than one temperature, so that is what we're going to be doing next. Alright, so the next thing we're going to want to do over here in our graph is we are going to want to plot it over many different temperatures. Right now we're just printing a graph over one specific temperature, but this graph will change depending on what temperature you're recording the volume and pressure at. So we're going to want to look at how the temperature is going to affect this graph, alright? So in order to do that, we're going to create a for loop for the temperature. So we are going to go for t in range. And for a starting value, we'll do something normal. We'll go with the boiling point of water, which is going to be 273. And then we'll go up to about 800 degrees. That's about a normal temperature you would be looking at. And this is in Kelvin. That is important to remember. And we'll do 25. This is going to tell us how many graphs we are going to be creating over here. And we want to do about 25. That'll give us a good idea of how the temperature is going to affect this plot over here. Alright, and then we'll add our colon in right there. And we'll go ahead and copy our function onto here. So this is going to give us the pressure at many different temperatures over here. So we'll copy that function on in there, get that deleted, and then we'll go ahead and copy our scatter plot so that it knows to create a graph at all these different temperatures. There we go, copy that on in there. Cut that away, like so. Alright, and then we're going to want to copy our make subplots function above here so that we actually have a plot to create these graphs in. Don't want to put that after the for loop, so we'll go ahead and get that up there. Alright, and let's go ahead and run this, see how she's looking. Give her a second. Running a little bit slow today. We'll get there one of these days. Oh, there we go. Alright, as you can see, we've got our different graphs going. And we are going to want to change the names over here. We don't want to just say like trace 0, trace 1. We're going to want it to say what temperature it's actually recording at. So we'll go ahead and get on into the function and change the names up. So in order to do that, we will go over here and we will put a comma, and we'll use the name function so that we can name our different graphs over here. And we'll go name is equal to, and then we'll go f t is equal to, and then we'll use the brackets so that it knows to use the temperatures that we're getting over here from our for loop. And then we'll throw a k in there so that we know the units. The units are going to be in Kelvin. And then since all these dots over here are going to be kind of overlapping in each other, it's going to make it real messy. So we'll go ahead and change this markers over here to lines. So that's plotting a line graph and not just a scatter plot over here. It's going to make it a lot prettier to look at. So we'll go ahead and change that to lines. And then as you can see over here, the graphs all kind of converge over on this side to the same point, and it makes the data not too interesting. So we're going to want to cut down our y values on that side a little bit so we can focus more over here where all the interesting shifts are going on. So we'll go back up here and we'll change this over to -2. It looks like we already did that earlier when we were testing. Alright, we'll see what that looks like. Alright, that's looking better for us. We are still going to want to update the y-axis a little bit over here. We'll create a new range for that so we can cut down on that side. So we'll go over here to fig.update, and then we'll change the y-axis, and then we'll just create a range for this one. So we'll go range is equal to negative 200 E6, and then we'll go 200 E6, and that should make our graph look a lot pretty over here. See what that's looking like. Computer's running a little bit slow today, and that does not appear to be what we're looking for right here. Yeah, it's not supposed to be looking like this. We must have made a mistake somewhere. Yeah, I'll look through this and I'll get back to you when I figure out what the mistake is. Alright, so after meticulously scanning every single aspect of the code, we found our mistake over here. It was a mistake in the parentheses. It always is with me. We added one too many over here, so we're going to go ahead and delete one of those. And I believe we needed an extra one. I believe it was right here. We'll go ahead and add that. And then check out our graph. Give this a second. And yeah, that is looking much better. That is exactly how we wanted to have it. As you can see, we have all of our graphs at the higher temperatures over here, just kind of making this little sideways U shape, and then as you get to the lower temperature, kind of gets a more fuller U shape right there. Then they all kind of converge over here to this same value over here, and yeah, that's exactly how you want it to look like. Yeah, that is how you plot the isotherm of the pressure versus temperature graph for water at many different temperatures. And yeah, have a good one, and make sure to smash like and subscribe.